Welcome back, STEAM Universe Academy engineers. Professor L here, and I am absolutely thrilled to activate Mission 006 of your Grade 8 Technology Practical Assessment task. You know, your freehand ideas were fantastic, but that was just the beginning. Today, we're taking those early concepts and transforming them into a real, precision-engineered 2D working drawing. We're talking about the ultimate blueprint for your Platinum Stars Minehead frame. So, let's dive right into this explainer and equip you with exactly what you need to absolutely conquer this task. 12. That's right, 12 massive marks. That is what this final blueprint is worth towards your Platinum Stars contract. It's a huge portion of your final score, and honestly, it's a critical milestone in your journey as an engineer. I want to see every single one of you secure all 12 of those marks. And to do that, well, we just need to follow the engineering protocols exactly, step by step with total focus and precision. Here's our clear flight path for today's mission. First up, we'll decode the brief. Second, we'll walk through the blueprint protocol. Then, we'll jump into active fieldwork. After that, we're hitting the engineering simulator. And finally, we'll wrap up with the clearance checklist. Let's kick things off with Section 1, the brief and its strict engineering requirements. Every successful engineering project starts with non-negotiable rules, right? So here is exactly what the examiners are looking for. Think of this as your toolkit and your rulebook combined. Your working drawing absolutely must be on square grid paper, and you've got to use a pencil and a ruler. No freehand wobbly lines allowed here. Precision is everything. Also, it needs to be exactly one face or view of your design. You must use a compass to draw the sheave wheel. You need to include at least 4 different dimensions for the main parts, and crucially, you must use triangulation to strengthen the structure. Oh, and above all else, it must be your own independent design. Let's pause on that structural requirement for a second. Triangulation. The PAT specifically requires your head frame to be made strong and rigid using triangulation. Why? Well, because triangles create a rigid structural arrangement. By adding diagonal structural members, you essentially break up large, weak rectangular spaces into really strong triangular sections. These sloping legs and diagonal braces, they literally prevent the heavy head frame from toppling over when it lifts that massive 10-ton platinum ore. Bottom line, if your structure doesn't have triangles, it just isn't strong enough. And this brings us to the absolute most important directive of the entire mission. The PAT is explicitly clear on this. You may not copy the drawing. You must draw your own design. See, this is an engineering design task, which means we're testing your ability to create a solution, not your ability to trace someone else's work. Engineering is all about creative problem solving, and your unique perspective is exactly what we want to see. Take a look at the example provided in your PAT document. It shows a small head frame design. It maps out the size of the sheave wheel, the height of the wheel, and the distance between the front and back legs. It's a really fantastic guide for understanding what a completed drawing should look like. But, and this is a huge but, if you simply copy this exact drawing onto your grid paper, the memorandum caps your potential marks at a maximum of just 6 out of 12. You literally lose half your marks instantly. So how do we use reference material like a real engineer? Well, you look at the example to understand the system. You use it to figure out where the sheave wheel generally goes, how dimensions are laid out with clear lines, and how a head frame is supported. But then, you close your eyes, you think about your own unique solution, and you create a structure that is entirely yours. Remember, your design does not have to look exactly like the example. Realistic alternative drawings are absolutely accepted and totally encouraged. Moving right along to Section 2, the blueprint protocol. Let's break down how to actually get this done. Staring at a blank piece of grid paper can be pretty intimidating, right? So we're going to break this down into an accessible sequence. Here's your 6-step roadmap. Step 1, plan your space so everything fits nicely. Step 2, draw the main structural members using your ruler. Step 3, add the sheave wheel perfectly using your compass. Step 4, add that all-important triangulation. Step 5, add your 4 dimensions. And finally, Step 6, inspect your work to ensure all corners meet and the lines are crisp. Let's look a little closer at that very first step. Before you even let your pencil touch the paper, just look at your blank square grid. Decide exactly where your head frame will fit. Whatever you do, do not start drawing right at the very edge of the page. You need to leave plenty of empty space all around your drawing because you have to add at least 4 clear dimensions, plus labels and extension lines. A well-planned page is a neat page, and trust me, neatness directly counts towards your final grade. All right, engineers, grab your gear. It's time for Section 3, Active fieldwork? Let's get interactive. Get your grid paper, a sharp pencil, a ruler, and your compass ready. We're going to do a pause mission right now. Actually, scratch that. Don't draw a single line quite yet. I want you to mentally map out your spacing first. Pause mission 1. Look at your grid. Where will your head frame actually fit? Where will your sheaf mill go? And where exactly will your 4 important dimensions sit so they aren't all squashed together? Pause this explainer right now. Take as much time as you need and make that mental plan. Welcome back. You've got your plan. Now for pause mission 2. It's time to actually start your working drawing independently. Execute steps 1 through 5 of our protocol. Use your ruler and pencil for the main structural members. Carefully use your compass to create a clean sheave wheel in a realistic position. Add those diagonal structural members for triangulation to make it rigid. And finally, add your form meaningful dimensions. Seriously, pause the explainer again. Take your time, take a solid 20 to 30 minutes if you need to, and draft your masterpiece. Awesome work. Let's transition into section 4, the engineering simulator, to test your knowledge. We're doing a rapid-fire knowledge check to make sure your blueprint is safe from mark-losing threats. Ready? First question. What specific engineering instrument must be used to draw the sheave wheel? And how many views are you required to draw? Think about it. Got it? The answers are a compass and exactly 1 view. Let's keep the momentum going. Next set of questions. How many dimensions are required at a minimum? What structural techniques simply must be included? And are you allowed to copy the example drawing? The answers? You need at least 4 different dimensions, you must include triangulation, and absolutely no, you cannot copy the example. Your design has to be completely your own. Let's quickly highlight those common traps that will instantly cost you marks. Do not copy the example. Do not forget to include triangulation. Your structure has to look realistic and strong. Do not provide fewer than 4 dimensions, and make sure they clearly relate to your specific design. Do not draw the sheave wheel freehand. If it's not a perfect compass circle, you lose marks. Do not draw multiple 3D views. This is a flat 2D working drawing. And finally, avoid messy, inconsistent lines. Keep that ruler steady. We are entering our final debrief, Section 5, Mission Clearance. I want to show you exactly how the examiners will grade your blueprint so you can secure all 12 marks. To score a good rating, everything needs to be on point. Triangulation must be visibly present, so the design looks incredibly strong and rigid. You need at least 4 clear, correctly indicated dimensions. The drawing itself has to be remarkably neat, accurately drawn with a pencil and ruler, lines meeting perfectly at the corners, and the compass clearly used for the wheel. And of course, the whole shebang has to be independently yours. Before you submit your PAT, I want you to run your drawing through this ultimate checklist with me. Ready? Is it my own design? Did I draw exactly 1 face? Did I use the square grid paper? Did I use my pencil and ruler for all straight lines? Did I use my compass for the sheave wheel? Did I include diagonal triangulation? Are there at least 4 different dimensions? Are those dimensions actually clear? And finally, does my structure look incredibly strong, rigid, and accurate? If you can say yes to all of those, well, you've successfully engineered a top-tier blueprint. So I'll leave you with this final, vital question. Look down at your page right now. Does your engineering solution look strong, realistic, and completely your own? If it does, be incredibly proud of what you've built today. You are well on your way to securing that Platinum Stars contract. Keep exploring, keep designing, and I'll see you on the next mission.